Today we're going to add and subtract rational expressions again. Difference this time is when we look through this, we do not have common denominators this time. So we're going to have to work to get those common denominators through a little bit of algebra. Okay, so let's start with number one. So we still want to subtract these things, but the only way we can subtract them is if those denominators are the same. Now I have to pick something to multiply each one by to make them the same. So I'm going to make the fraction bars a little bit longer. That's did a pretty poor job with that. Let's try that again. Not much better, but a little bit better. And the easiest way to do this is I'm going to take the expression from the denominator of either side, and that's what I'm going to put over here. So for the first one, the number that I'm going to put on top and bottom is this expression down here, this x plus 6. So this is going to get an x plus 6. And I'm going to also get it up on the top as well, because that would be a common factor that would cancel out, and I'd still have what I started with. It doesn't really change anything, but I'm going to change the way it looks to get that common denominator. Then I'm going to take what we started with over here, that x plus 3, and I'm going to write it top and bottom on this fraction, because what I've done now is I've made common denominators. So now we have common denominators here. This is the same thing, and nice thing is it's already factored, unlike the stuff that we were working with yesterday. So that means that I can write this all over one of these denominators, the x plus 6, the x plus 3, and then the top I just need to do this subtraction operation. So I'm going to have 3x times x plus 6, and then I need to subtract from that whatever 6 times x plus 3 is. So I need to simplify the top and then deal with any common factors or anything else first. So it means I'm going to need to distribute this, and then I'm going to need to distribute that before I do the subtraction and combine like terms. So denominator is not going to change at all throughout this. So we have x plus 6, x plus 3 on the bottom. So let's distribute here. 3x times x is 3x squared. 3x times 6 is 18x. Now we're going to leave this minus in here and draw this little bracket, and we'll distribute that in a second. But 6 times x is 6x, and 6 times 3 is plus 18. Now we know that this is going to make both these things negative, so I'm going to come down here and rewrite what we have. So the denominator still hasn't changed. It's still x plus 6 times x plus 3. And our numerator here, we have 3x squared, and we are going to add 18 to that, 18x, and it's now minus 6x and minus 18. So now we're going to combine like terms. Bottom still hasn't changed, so we're only working with the top here. So that's x plus 6, and this is x plus 3. And so 3x squared, nothing combines with that. The 18, nothing combines, but these two are going to combine and turn into 12. So that's 3x squared plus 12x minus 18. So now as we go through and we work with this, we have a quadratic on top that we're going to need to factor. Now, before you do that, we work with the factoring. Let's pull out its common factor of 3 and see what we have left. We have x squared, and then 12 divided by 3 gives you 4. And 18 divided by 3 is going to give us 6, right? Sorry, I drew the wrong bracket there. Bottom, all this process still hasn't changed. It's just kind of along for the ride. So what we need to factor is we need to factor this x squared plus 4x minus 6. So because now we made this 1, we're looking for the factors of 6 that have a difference of 4. So let's list the factors of 6 over here and see if anything happens. So we have 1 and 6 and 2 and 3. Are any of these going to give us 4 any way we subtract them? Nope, 6 minus 1, 1 minus 6, not going to work. 2 minus 3, 3 minus 2, that's not going to work. So that means that this isn't going to factor into integers to make any of this cancel. So that means we're done with this one. That is the answer. So unlike ones we did yesterday, where a lot of stuff canceled and a lot of stuff factored, it doesn't always have to happen. This could be what we end up with just like that, okay? So let's try that second one. So before we go on and we do anything with the second one, we're going to get common denominators, but we should go through and factor anything out that's easily factorable about each independent fraction, just like we did when we first started this. So let's look at this, the 6p plus 30. These have a common factor. They have a common factor of 6. And now 6 and 2, since we're multiplying down here, this can factor into that, meaning that this should really be written as 1 over 3 times p plus 5. That's going to be important because when we got a common factor of 2 out, it'll going to make the math a lot easier over here. So this first expression over here turns into 1 over 3p plus 5. And the second expression has not changed. It's still 6 over p plus 4. Sorry, p minus 4. Now we need common denominators. So we're going to take this one and we're going to write it on the other side. So this is going to become the top and the bottom on the other side. Let's write it in red so we can see it a little bit easier. So this is going to be p minus 4, and this is going to be p minus 4. And then we're going to take the denominator here that we had, and that's going to come over here on this right side. So that means we're going to get a 3p plus 5 right here, and a 3p plus 5 right here. Now the denominator is not going to change throughout this whole process. So we're going to write that out as 1 when we go and combine the top. So we have 3p plus 5 times p minus 4. All the work from here on out is going to take place on the top when we go and we distribute and we go and solve this thing. So we have 1 times p minus 4. That's just p minus 4. Plus 6 times 3 is 18 times p plus 5. So let's go ahead and go through and distribute and solve, distribute and simplify the stuff on the top, okay? So we're going to need to distribute here and then combine like terms. So the numerator on this turns into p minus 4 plus 18p, and now we got to go 18 times 5, which is 9 times 10, so that's got to be 90, plus 90, and the bottom still has not changed. And we're always going to leave the denominator factored for these problems because factored is always the way we want to show our answer so that we can show that nothing cancels out. All right, so 18p plus another p is 19p. And now we're going to go minus 4 and 90, that's 86. And this is 3p plus 5, p minus 4. So now we need to look for common factors in this. 19's prime, so that's not going to work. So we're done. That one's factored all the way down. There's nothing else they can factor out of the top to cause anything to cancel on the bottom. That's all she wrote with that one. So just remember, common factors, factor your fractions first. Common denominators, factor your fractions first, then combine the tops. Let me know if you guys need any help. I'm here to help you.